Namaste. I welcome all of you for the next session. Today we are going to begin the chapter Real Numbers. So there's a very first chapter in your lessons. So we will see what is it all about, how are we operating the numbers in the real system, and what is the connectivity between one system to other. All these things we are going to see. So earlier, when we are first introduced to the school, when you are first introduced to the numbers, always we learnt about natural numbers, isn't it? We say that the numbers 1, 2, 3, etc. up to endless, maybe it is infinity. At that age, you would not have been introduced to infinity, but the numbers go without any ending. It goes on like that. So we named it also as a system of natural numbers. Okay. So the numbers, this is the first thing you learn, and we call it as a system of natural numbers. Now, as and when we operate on this number system, we studied how to represent them on the number line and how does it behave with respect to the basic 4 operations: addition, subtraction, multiplication and division. So when we did those operations, we came across certain situations like 1 minus 1, 2 minus 2, 3 minus 3, 3 divided by 2, 2 divided by 4. So, these things, they don't have a representation as natural numbers. So, we have to create another system in which we can represent or address these situations also, isn't it? So, for that, we introduced a 0 into the system, and we studied about 0, 1, 2, 3, etc. up to infinity, and we called as set of whole numbers. So again the whole numbers, the set of whole numbers is not satisfying certain relationships, like we have 3 by 2, 2 by 4, 1 by 4. So one we have to divide by 2 by 5 and then 5 by 2. So we don't get a whole number as the answer. So that becomes incomplete, isn't it? So we introduce a set of fractions. And then the fractions next to the decimals. How for every fraction there is a decimal representation, and every decimal there is a fractional representation. So all these concepts you studied. Now again it becomes incomplete. Okay, so the fractions we have got, even though we don't define it as a set of numbers, we introduce the fractions and things like that, okay, related to that. Now sometimes this also becomes incomplete. So whenever we studied about the basic 4 operations, whether it is fractions or whole numbers or natural numbers, we always learnt that it is always possible to subtract a number. Only from a bigger number we will be able to subtract, and when we come across such situation, we don't have a representation. So when we know only about the positive numbers, and that too from 0 to infinity, and also the fractional numbers, okay, these things are okay, we can do that. But when it comes to such situations, we don't have a representation. So there is something that we have to do more. Therefore, we introduce some more set of numbers, and those numbers we call as integers. So how do we define integers? It's the set of numbers from minus infinity to plus infinity, and then the 0 being the middle number. From 0 to infinity, one number system goes on increasing, and 0 to minus infinity, it goes on decreasing, so that we are able to represent quantities like minus 10, minus 7, minus 8, the temperature, the absolute temperature of 273 degrees C and things like that. Isn't it absolute scale? In the absolute scale and all that. So this kind of representation became possible when or after introducing a set of integers. This set of integers we define like the counting numbers from minus infinity to plus infinity, and then we call it as set of integers. So number system has included this set of integers also. So all the integers from minus infinity to plus infinity can be represented on a number line, and we will be able to perform operations. And then what about these fractions? When we entered after the whole numbers as fractional numbers, we consider only the positive. And then after learning the set of integers, even the negative fractions are also making sense. Therefore, we have divided the numbers, or we included one more set of numbers as rational numbers. And then these rational numbers, positive and negative fractions were also included. In order to understand better, when we say that from between 0 to 1, there are so many positive fractions. In the same way, between minus 1 to 0, and this is 0 and this is minus 1, in between so many points are there, and each and every point or each and every representation is a negative fractional number. So when the positive and negative fractions put together, we derived a set of numbers called rational numbers. So these rational numbers includes everything. What all? It includes the set of integers, it includes the set of whole numbers, it includes the set of natural numbers too. How? Now when we say that rational numbers, minus 2 by 3 is a negative rational number. Okay, agree. What about this 2 by 3? That is positive rational number. Agreed. Now what about number 1? It is still called a rational number. Why? We can always write this 1 by 1. Okay, so it has got some connection. All the whole numbers and the set of integers, they all have got some representation in the set of rational numbers. Okay, so we can define like this. 6 can be written as 6 by 1. Nothing is there in the denominator means we can always consider as some number 1 is there. Therefore, it becomes a rational number. If there is minus 6, there is always a rational number minus 6 by 1. It is the value wise, it is the same as that. Therefore, we are comfortable in handling such numbers. So when we define the set of rational numbers, we have to give a definition. What is that correct definition? Numbers which can be represented in the form P by Q, where P and Q are integers, right? But the Q is an integer which is greater than or not equal to 0. So we define the set of rational numbers as the numbers which can be represented in the form P by Q, where P and Q are integers and they don't have a common factor between them. And another condition is that Q is a non-zero integer. Q is not equal to 0 in any case. Are you understanding? This is called a set of rational numbers, and we are comfortable to handle all such integers, whole numbers, natural numbers. It includes everything. Okay, every whole number is a member in the rational numbers. Every integer is a member in the set of rational numbers. Every natural number is a member in the set of rational numbers. But every rational number is not a member of these things. Can you just quote an example? Suppose if I take 2 by 3z. 2 by 3 is not an integer. It is not a whole number. It is not a whole number. It's not a natural number. It is not an integer. Therefore, but when you write 4, 4 is a rational number. 4 is a whole number. 4 is a natural number. So like that, we will be able to compare and contrast the different set of numbers, and we were comfortable with rational numbers. Again, some situations occurred. How? Suppose if we find the square root. Okay, if you find the square root of 5, you will write as plus or minus 5. Can be either plus 5 or plus minus 5. When you write the square root of 36, it can be plus or minus 6. That is, it can be plus 6 or minus 6. You know why it is like that. 6 into 6 with a negative positive sign is also 36, and minus 6 into minus 6 is also 36. Therefore, when you are writing like this, it's okay. Now, 1 square root of 1 is 1. The next perfect square is 4. So the square root of 4 will be plus or minus 2. The next will be 9. They are all whole numbers, and then they are perfect squares, and we get. Now what about the numbers which are not perfect squares? Like you have your root 2, you have got your root 3, root 5, root 6. They are all non-perfect squares. Are you understanding? Now, when you attempt to find the non-perfect square's square root, when we find the square root of perfect square, we get a whole number or an integer or a rational number or anything you will get. But when you attempt to find the square root of non-perfect squares, what do we get? We don't get a integer, we don't get a fractional number, we don't get a rational number, we don't get a whole number. Like for example, root 2 we have to find, say. I will show you in the class, in one of the sessions, what is the value of root 2. So root 2 or root 3 or root 5, if you are attempt to find that, you will get some kind of number representation like this, and then plus etc. It is going up to infinite number of places. Therefore, it has got a connectivity with the decimal numbers. So what we studied? We studied that every rational number can be represented as a decimal number. When we introduce fractional numbers, when we introduce rational numbers, we studied that every rational number or every fractional number can be written in the form of a decimal. The decimal may be terminating or non-terminating, but the terminating decimal, there is no problem. We can get it like half, 1 by 4, and then your 1 by 10. They are all terminating decimal expansions. 0.5, 0.25, 0.1 like that. But when we considered the decimal expansion of 1 by 3, what will happen? When we attempt to find it, you will end up with 0.33333 to infinite number of places. Now, we have also studied that just because we are able to write this decimal, we as a fraction as 1 by 3, even this belongs to the category of rational numbers. Because we were able to express in the form p by q. Right? Therefore, any repeating decimal, any repeating decimal of this form, it can repeat after 1 digit, 2 digit, 3 digit, 4 digit, like you got 1 by 17, it repeats after 16 places. So, any repeating pattern of decimals also, fall into the category of rational numbers. Are you understanding? But there are decimal representation like 1.253 ... I cannot write it. If I know 3 places on division, okay, that much I can do. But what is going to come in the 4th place, I cannot guess, like a repeating decimal. What is going to come in the 6th place, I cannot write like a repeating decimal. These numbers are also existing. When we attempt to find the square root of non-perfect squares like root 2, root 3, root 5, root 11, root 10, they are all non-perfect squares. When you attempt to find the square root of such numbers, what will happen? The decimal will not end, point number 1. The decimal will not have a repeating pattern. So, that will not end and not repeating pattern, okay, we will come across, and those decimal numbers cannot be converted into a rational number of the form P by Q at all. What we do while handling those numbers in problems, we just generalize it, or we will be able to approximate it for 2-3 decimal places and proceed. So even if you divide it for, even if you attempt to find, okay, in 7 places, 100 places, 70 places, 200 places like that, we are not able to find out what is going to be the next number. Okay, what is going to be the next place digit in the decimal form. Such numbers are also existing, and such numbers can also be represented on the number line perfectly, and therefore we categorize those numbers as irrational numbers. The numbers which can be represented in the form P by Q is called rational numbers. The numbers which cannot be represented in the form P by Q are categorized as irrational numbers. Now, these rational and irrational numbers put together we call as real numbers. We call as real numbers. In this, the irrational numbers are also finding a place, and then everything put together, we call it as a set of real numbers. In the set of real numbers, there are irrational numbers, there are rational numbers, there are set of integers, there are fractional numbers, there are whole numbers, there are natural. It covers a big circumference, so that all the numbers that we have come across so far, or we have learnt so far, will be put into this category as real numbers, and about that we are going to study in this chapter. Now, listen. Now, do you think that the number system gets completed with that? No. We have got one more system of numbers. That is for your next class. And that number system we call as complex numbers, about which you will study in your core maths specialization in the next classes. Now, as of now, you should understand that real numbers encloses every number that you have come across so far, and about that we are going to study in the next sessions.